So I propose we start this webinar about ensuring connectivity in crisis and how to support resilient communication for emergency responders. This is the fourth webinar organized by the Direction project with the support of the DRS Hub, the DRS stakeholder hub from CMINE. I will introduce the webinar. So my name is Olivier Salvi. I am the coordinator of the Direction project, which is a network on disaster resilient society, also manager of Ineris development. For this webinar, we will have three speakers. David Lunt from the Public Safety Communication Europe, PSCE, also very well connected with the EUCCS. We will have our colleague George Kokinis from KEMEA, the research institute in Greece, and Nicolas Savage from Accelerate Technology, so a company which has been awarded by Direction because they propose a very innovative technologies that you will discover in some minutes. During this webinar, I will remind you with briefly about the Direction project, about the work of this network, and also the connection with the DRS Hub. Then we will have the pleasure to hear David explaining what is the state of preparation for this European critical communication system, which will be very important to assure a resilient communication in case of major crisis in Europe. Then George Kokinis will present the state of the art and the evolution of the different communication technology. So it's a research perspective. And the third presentation from Nicolas Savage. She will present one of the technology developed by the Accelerate Technology Group. After this webinar, after this presentation, I will take the question that you can write in the chat, and we will have some answer from the speaker. So I hope this webinar will be very informative for you on this topic. Just to mention as an introduction, we are having this webinar as part of our contribution in the Disaster Resilient Society Stakeholder Hub, which is an initiative that proposes a sort of one-stop shop, a single entry-level reference point for everything related to this disaster risk management. So if you want to know project on this topic, share information with the community, find tools, so you can visit this website to get information. The webinars that are developed in the framework of the DRS Hub receive the contribution for more than 40 projects, and we address both the societal resilience and the responder technologies. And so it's a good way to have cross learning between different projects on what is going on in terms of technology, in terms of standardization, in terms of good practice. So I invite you to visit the drs-hub.eu website. Some words about the Direction project that I am coordinating with Bastien Kaya, also, who has organized this webinar. The objective of the Direction network is to promote innovation and facilitate the technology uptake in the field of disaster resilient societies. So what we do, and you see on the left-hand side of the presentation, what we do, we try to understand the capability gaps of emergency responders, identify what are the needs so that they can do better their mission, protect themselves during the operation. When we have identified the capability gaps, we make some screening with research organizations like KEMEA, like Fraunhofer, like TNO, who are involved in the project. And we identify innovative solutions. Some of them are not well known across all Europe. So one part of our activity is to promote this innovative solution so that they find more users, and we hope that these innovative solutions are useful for the emergency responder across Europe. So we create or we develop a co-development environment, so bringing together solution provider and end user, so that the solutions that are developed meet perfectly the expectation of the emergency responder. So we have different activity in the network. We are interconnected with many other networks. We also devise and recommend some topics for research based on the needs that are not covered by existing solution. We support and create an environment which is favorable for co-creation, cooperation between solution developer and emergency responder. And also we try to facilitate the procurement of some of the technologies that are innovative. There are many tools that exist, like pre-commercial procurement, procurement of innovation. So we try to promote these tools available at European level to purchase innovation. So that's all regarding what I wanted to say about the Direction project. So I would like to give the floor now to David, so you can take the control of it and present the EUCCS. Thank you.
Okay, thanks a lot, Olivier. I hope you can hear me okay. I think the microphone's working. I think it's good. Right, let's go. So thanks a lot for inviting us to make this presentation today. What we're doing here is preparing to establish the EUCCS, the European Critical Communication System. It's important to be aware of this because it will be a new communication capability across Europe for responders across Europe, and there will be many future opportunities, I would say, for innovators and that can develop, these advanced technologies, situational awareness services that will, of course, make use of it. What we're building is a mobile technology that's a hell of a lot more reliable and secure than your mobile phone in your pocket. So this is the crucial target we're aiming for. I'm going to begin with a video just because it can explain it a little bit better than I can. And then I'll come back with some insight in our journey so far. As Olivier mentioned, the pre-commercial procurement programs, we've done that. And the policy path which led to the policy path towards establishment of the EUCCS, then what we're doing to prepare for EUCCS, and finally, I'll explain how you can all get involved in this program.
A war is ongoing. The challenges to counter crime and terrorism have become more complex. Cyber threats to our communication infrastructure are increasingly sophisticated. The climate emergency is upon us. Our society faces increasingly complex hazards and insecurity. Our police and emergency services work together tirelessly to keep us safe in our daily lives. But disasters don't respect borders, and as responders move around, technology is not keeping up. Their missions are critical. They need mission-critical mobile communication. Responders need better technology that is fit for purpose, works anywhere, is secure, reliable, resilient to cyber threat, and trustworthy. Technical and legal boundaries should not be limitations when cross-border and pan-European cooperation can keep society safer. European Commission services and experts from EU member states are leading the way to establish the European Union Critical Communication System, also known as EUCCS. This EU-wide mobile communication system will make operational mobility possible. Responders will be able to carry out their operations wherever they are, whenever they need to, and cooperate with whoever they should. Project Broadway set the stage. It provided the confidence that the standards and technology have the potential to realize this European capability. EUCCS preparation will provide the support needed to prepare the technology and operational procedures for use of this new mission-critical mobile communication capability. EUCCS preparation will involve experts from most European Union member states and Schengen countries to develop interconnected national testbeds to further explore and de-risk the technologies that will make this capability possible. Active responders will use EUCCS preparation to trial existing new operational procedures for pan-European collaboration. Responders will consider new ways of working when they are tasked to respond internationally. As EUCCS preparation will trial mission-critical mobile technology and procedures, it will also consider what policy might be needed. European Commission services have created a mission-critical communication expert group to work towards defining a governance and preparing for deployment that will be needed at the European level to support establishment of EUCCS. Experts from all European Union member states and Schengen countries are involved. EUCCS preparation will work alongside the MCCG to advise on technical matters. Operational mobility, achieved through EUCCS, allows our European responders to work towards a safer and more secure Europe, in ways that are not restricted by borders.
Okay, so hopefully that gives you an overview of what the goal is, really. This is a challenge, really, a huge challenge to create this new system across Europe. But we do have the right team around us for this, which I'll explain shortly. So this realizing of operational mobility, the ability for responders to carry out their operations wherever they are, whenever they need to communicate, and with whoever they're tasked to cooperate with. So this is a revolution, kind of revolutionary in a way, because if you're looking at the Tetra networks around Europe, they're very isolated within their country borders. And what we do is we provide solutions which can cover the communication gaps there by using off-the-shelf technology as it is now. But we know that this technology is not the most reliable nor secure. So what we're trying to do in the EUCCS is make that whole system across the entirety of Europe secure and reliable. So it's quite a challenge, really, but we have been working on this for quite some time. I'll give you some indication. Many of you will be involved in the Horizon 2020 or framework projects before and so on, and Horizon Europe now. We go back more than 10 years now. In 2014, we wrote a proposal called Broadmap. You'll see it on the slide there. This is where we carried out a kind of requirements validation. What does the European response community need in terms of mobile communication? This then fed back to the European Commission. This is DG Home Affairs, which led towards the Broadway project, which was actually a pre-commercial procurement project that was mentioned earlier. So we were the first really big PCP project in the security domain. Quite a challenge, I'll be honest. But that led then back to the policy. So I'll explain some of the detail of where we are on that now. In Broadway, we had the PCP process, design, prototyping, and pilots. And you can see the contractors involved there. Very large industry. And what we do with this process is put them in competition with each other so that the outcome is the best. You never have the best budget in PCP, but the outcome, it's an incentive, and the outcome of the project was to us, yes, the technology is available towards realizing the pan-European system, and it would actually be a pan-European system of systems because each country will have its own sovereignty to actually create its own national mobile broadband system in the same way it has its own national Tetra system or Tetrapol. So we completed Broadway around 2022. The outcome of 3 major trials, but the image on the screen there is the trial we had in Malaga, where we had a ferry fire trial with lots of responders, lots of vehicles, 50 responders we had on that trial. And it gave us some, I would say, confidence that the technology is nearly ready, but it's not quite ready yet. The other thing that happened when we went back to the Commission is they saw, well, actually, there's some legs in what we're doing. There's some benefit coming forward. The technology is nearly ready. The motivation is there. So it led to a number of policy points, policy intervention points, documents being written back to 2021, the protection of public spaces council conclusions, which are actually a response in a way to the Bataclan incident in Paris a number of years ago. Then it led towards your Law Enforcement Working Party in the European Council. The Space Strategy for Security and Defence referred to our work. The Mission Critical Expert Group was formed, as was mentioned, and then a number of political policy points were progressing towards the recent European elections. And as Ursula von der Leyen was re-elected to be president of the European Commission, she published the political guidelines, which is in the middle, described. And the political guidelines explicitly mentioned the establishment of a European critical communication system. So the outcome of our earlier Horizon 20 projects, Broadmap Broadway, led to this policy initiative. A number of further reports, the NINISTO report, the internal security strategy, the preparedness union strategy, all of those items, all of those documents referred to the establishment of the EUCCS. And finally, just 2 months ago, the European Commission Work Programme for 2026 was published, and in this year there is now going to be a draft regulation tabled, presented probably in Q3 of this year, which will legally establish the European critical communication system. And of course, that is carried out with the experts of the MCCG. They're experts from every member state. So you can see there the establishment, the pre-legislative proposal we expect in Q3 of this year. A Mission Critical Expert Group, as I mentioned, was established in 2023. Earlier this year, in May, they agreed this operational plan, the plan for developing the European critical communication system. So these are the experts from each member state. It's all public sector, it's all governments. So the experts come from either the Ministry of Interior or the delegated agency in their country. So that's a representative from all EU member states and Schengen associated countries. So 31, 32 countries around the same table, providing experts on how EUCCS should be. Our project, EUCCS preparation, as we progressed forwards after Broadway, DG Home Affairs then provided us with a grant to continue the activity, continue the technical exploration, continue preparing towards, I would say, elaborating the standards that are needed for every country in Europe to be able to implement a compatible mission critical service communication system, mobile communication system. You'll see a list there. There's 16 joint procurers. You'll count 18 countries in the list actually, and you'll see further countries starting to become involved. So Germany have signed, Luxembourg, Switzerland, Portugal, and Iceland are still in consideration. But this is the technical element of the project. The MCCG has all member states set in the law, and here this is the technical investigation. So we're 18 plus however many extra countries around our table developing and trialing technology with the test beds. Now, when it comes to standards, it's very important to understand that in public safety, we have a very different need, I would say, for standards. At the bottom there of this diagram is the 3GPP standards. You'll see the physical interop, protocol interop, data object interop, informational interoperability. So they're the technical elements of everything that we're doing primarily in our community, I would say, in the technology. As a consumer user of a mobile phone, it's only the bottom two layers of this diagram that ever matter. Everything above it with regard to public safety response, aligned operations, aligned procedures, knowledge awareness. Knowledge awareness is where the actionable information, not where decisions are made on actionable information. And that information needs to be delivered on time to the right person to make the right decision. And it's very important to have the procedures and operations in place to allow that to happen, especially in high stress crisis situations. The knowledge awareness element of this is pretty key. And this is the thing that's missed, I would say, in a lot of the technical standards. This diagram here will be released publicly this week, probably early next week. We've developed the high-level concept of operations. Here, we define 4 countries, or we illustrate 4 countries. You will see different, I would say, circumstances. You've got rural, you've got urban, you've got a desert, you've got an island. These are all different aspects of different regions of the different areas of Europe. On the circle on the right, you'll see a response incident being shown. Here we show the additional coverage. So you'll hear from Nicola later about technologies that can cover where infrastructure is destroyed. It doesn't matter how well we build the EUCCS. There will be situations where the infrastructure is damaged or not available. We have satellites in the sky here too. There are a number of different problems to solve around development of EUCCS. But EUCCS preparation, our program that we coordinate, is taking steps to investigate all of these problems well before the live system is in place around 2030. So at the moment, we're building a test bed. We have 4 vendors, Airbus, Frequentis, Leonardo, Teltronic, and each of them provide free mission-critical server deployments for a total of 12 countries. And the national test management teams here are representatives of their ministry or agency in their country responsible for this. So we're working with the right levels of people in all around this. The challenge really is can we actually have those mission critical servers interconnect? Each server will manage the talk groups, the communication groups in their country. If there's an incident on the border, for example, let's say there's a road traffic accident on the border of France and Belgium. The Belgian fire responder arrives on the scene first. He needs to talk to the French team. However, if he was using Tetra technology, he wouldn't be able to do that. But if we're using an interoperable mission critical services, their talk groups can be patched between the 2 servers and work together. So the control rooms can organize, well, this talk group on fire in Belgium, needs to talk to the responders in France related to the response coming, because the paramedics and the police will come from the France side, but they all need to talk together. And the idea is that EUCCS will enable those talk groups to be joined together dynamically or developed before the actual incident or whatever. There's plenty of operational challenges going forward. And when we look at operational, we have a technical team, but we also have an operational team, the operational procedures team. What they're doing is coming together to anticipate how this new technology, this new way of working may be useful for them. How do they work together? You got different responders from different disciplines, from different countries, and it's quite unique, really, to see that. And apart from these, high-level crisis situations that you do see, especially with DG ECHO, ERCC type response, but what we're doing here is preparing these operational procedures in light of EUCCS being available and in use. So what they're doing, they're carrying out tabletop exercises, they're getting together online. We don't do as much of that now because they now have devices in their hands. They get together. My slides have gone wrong. They get together in person. They do online tabletops. My slides are wrong. Sorry. Then we do pilot trials, physical pilot trials. Earlier in last year, we did some flooding trials in Germany, Sweden, Italy, and Netherlands. Then in Stockholm in June, July, sorry, we had a multinational sea and land drugs chase with responders from all over Europe, all different disciplines, and so on. And in Italy, in November, we held another large-scale trial. More than 100 responders were in play in this event. Nice photograph. We had helicopters, we had ships, we had vehicles, we had a lot of responders. And I'm just going to show you a nice video of what happened there.
Your position should be on the boat. Perfect.
Ma noi abbiamo dispatcher copy.
Police B land for dispatcher B land.
Go to land B.
We have SOS by boat between the C and B border.
This is the police, you have to...
Ask something at your level in international channel, police.
So you'll see we're quite busy with regard to the technical preparations. We're busy with the assistance to the European Commission, DG Home Affairs leading the preparation of the pre-legislation proposal. So this legislative proposal will be made again in Q3 this year, which will table for establishment of the EUCCS in the 2030 timeframe. 2030 will be the starting point really for the EUCCS. Some countries will be integrated, not all, but it will be a gradual. When a country is ready, they will join. Eventually, we will have all countries be a part of the EUCCS, so that responders can roam wherever they need to in Europe and carry out their operations using the same applications, same devices as they would do at home. They cannot do that now at the moment today. So my message is get involved. Okay, we have a huge challenge in front of us, and we have a huge team as well, but it's open for all of you. So the continuous innovation is key through EUCCS, and it's part of a plan. So whatever you're developing and going forward with, please let us know. Align your technical capability with EUCCS. We're happy to help guide on that, no problem. If you're a practitioner, a responder, we can invite you to the trials. So please come up, please make yourself aware if you want to be doing that. We have 2 conferences a year. This is where you'll find out most of the updates of what's going on. If you have a piece of kit, piece of development, piece of software that you wish to show or trial, please come and talk to us, because we can elaborate that out. We can show it out to the rest of the team. And it's possible even that we can even integrate new technologies, new innovations into the trials that we're carrying out. So I'll close it there now. So thanks a lot, Olivier, and thanks to everybody for listening. Available for questions later.
Thank you very much, David, for your presentation. It was very informative to see all the history of the development of this initiative with the Broadway project series. I think it's also very informative to see all the work that is done to coordinate the member states. We see not all of them are already involved, but we hope that it will be throughout Europe just after 2030 when it will be implemented. So thank you very much. I propose that now, so you have a next slide that says thank you, and then we move to the next speaker, who will be George Kokinis. Exactly. So George, please tell us about the evolution of the different technology on this in this field of resilient communication.
Okay, thank you so much, Olivier. My name is George Kokidis. I'm from Security Studies in Greece. We are supervised by the Hellenic Ministry of Citizen Protection. It is kind of privilege for me here to be here among you because as Medea coordinator, I'm really happy to see that Direction took some of the research out of Medea and actually, they keep working on. And it's always challenging to take the floor after David to speak about EUCCS because EUCCS it is mostly part of David's, own journey for that. So in the next 20 minutes, I would like to share some research insights about the evolution of critical mission communications and how they're going to transition to what we call EUCCS. So it is important to say that it's not going to be kind of technology discussion. David speak about systems. We're going to have to speak about system of systems, pardon me, and also governance, security, and operational reality. So let me start by framing the core difference between legacy and EUCCS. So what we're talking about. So it is important to have a journey, and the journey starts with Tetra or similar systems like Tetrapol, and all these systems started around 30 years ago. Our Tetra has been, let's say, mostly for voice, mission critical voice, and was the only dominant system that 3 decades ago allowed most of our responders to use it and had in mind to be extremely available, to be resilient, and optimized for some, let's say, group calls. But since 1995, many things have changed. We have went to the smartphone era, and now we have to see how our first responder, we can use not only voice, but actually data, video, and critical awareness. So we have to transform from, let's say, from voice to all actually rich multimedia, but secure communication services. So for 2015 and for the, let's say, next 15 years, we're entering, and actually we're in it, in a transition phase. So people starting moving from Tetra to, let's say, more advanced network and have more advanced services. And actually right now we're going in a phase where we have, let's say, we're going to operate for now on, and some countries we will do in the near future, they're going to operate two networks, one for primary services and kind of Tetra from fallback. We cannot, switch overnight from, let's say, a Tetra legacy system to, new EUCCS system. So this transition is going to take place, and as David said quite a few times, it is not that straightforward because technology is there, but it is not that easy. So, and actually from 2025, 2030, we're going to move to what David, has fully described as EUCCS, which is going to be kind of, let's say, broadband, public disaster and resilience network. So over there we have ultra low latency, secure applications, advanced situational awareness. People, you can use drones, body cams, real-time analytics. So you're going to be like the first responder you have seen on the first slide from this webinar. So there is some time ahead of us to do that. But this also it's important to see what is the reality check. What changed for the operators, what changed for first responder, what changed from authorities. And moving from something that was, let's say, an old network to a new network is not that straightforward. It is a matter of who owns the network. It is a matter of governance. It is a matter of regulation. David mentioned many EU regulations. So these EU regulations have brought into the States safety, security. Some countries, they have also to consider, defense forces, not as defense military use, but sometimes army takes over in some, let's say, response. So voice certainty, and we have to consider how from voice we're going to build, let's say, all this functionality and have this information superiority. And we have to speak about physics. Tetra has limited number of sites. It was over there for resilient. And for these services, we have to enrich the network to start building more capacity. So we have to have more dependencies in order to achieve this network. It's more complex. And apart of the technical aspects, it's not only technical aspects, it is policy decisions that each EU member state has to decide, has to be aligned with other EU member states, because cross-border incidents should change also our modus operandi. And you have to have, as you have seen from the operational procedures team, new revised concept of operations. So all these things have to change. So we don't only move from one old network to a new network, we also change mentality, and we also change gear, and from voice we have more capabilities, and this is not that as straightforward as is. So have, let's say, a comparison what is Tetra and what is broadband PPDR. So from the one side you have voice, from the other side you have more functionalities, more services, videos, it's awareness, but Tetra was well described. It was kind, let's say, well regulated. We have some specific frequencies. And 30 years ago, all the people in the world knew that this is the Tetra frequencies. And right now, in order to have all this, move from voice to more multimedia services, you have to find more frequencies. And the situation there across Europe is not harmonized. Each country has its own, spectrum strategy. They have also have some, let's say, allocations of frequencies, because up to that point, frequencies spectrum has nothing to do with PPDR. Usually spectrum comes with money, comes with spectrum, and having in mind that in 2025, 2013, we're going to have this PPDR, let's say, network with this kind of functionality, at least many EU governments didn't foresee this, or actually when they realize it, they have already, release and reallocate to the spectrum to some, mobile operators. So this is going to be not an easy stuff. That's why we need this transition phase. We need this hybrid approach. We need to go from, let's say, 4G to 5G for a number of reasons, and mainly it is spectrum most of the time. So what happens to the spectrum? Who regulates it? So it is the International Telecommunication Union that actually, every 4 years have this conference, and they give the pace of what will be and what will happen in the next years. So it is critical for not Greece, but for many countries to start thinking and planning how to will reserve or actually best utilize frequency that is now allocated for commercial, communications, how they're going to be co-located and co-share and have this mission critical communication. So it is challenging. So it is not only allocating the Europe, but we need kind of regulation. We need to harmonize it, and most likely, not for sure, we need to license it. And also, as we have seen, and we will see, we need more sites in order to have these multimedia and rich services, but more sites has an additional cost. So we're talking here let's say, of a capex. So if Tetra was costing X amount of money, this new envisioned EUCCS network will cost at least 5 times more. And 5 times more is the minimum threshold, because depending what is happening with the network, what is happening with the resources, what will be the model of deploying the network, the cost is going to rise, and I will explain shortly what do I mean. So the below of the picture that you see, we have the Tetra. And Tetra was kind of a silo. It has only in one, let's say, vendor. So you have the security, you have the RAN, you have the core, and all this come with Tetra, and the spectrum. Now you have to have services, mission critical services. That's why we have seen the acronym mission critical video, mission critical voice, mission critical data. So you have services and you have a core, and this core is going to be own, partially control, partially, do something, and you have services. So the next generation network is going to be services over a core that is going to be technologically mature, but we have to find models and agreements of how to use it. So again, this summarize it. So it is not only who has the mandate for PBDR communication, because with Tetra, more or less, the situation was crystal clear. So safety practitioners who have the thing, and it was let's say, of one responder or one network per country. Now we have to have one authority that will try to accommodate all first responders in one country. And actually this authority has to be in connection with other authorities in order to enable this cross-border, interworking. So Tetra Core was something really, really simplified. Now we have, let's say, 4G, 5G core that has to be there. It is more complex, so you need people to maintain it, and you also need some control of it, because core, it is the decisive point. So when you have, let's say, a disaster, who's going to use the resources? So some people have to have the authority to move and allocate frequency and bandwidth to the people, to the first responder who actually, working on the situation. So this has to be regulated. So technically, as a capability is there, but needs to be regulated, needs to be agreed, and needs actually to be kind of this national strategy. Transport is going to be more or less the same, but we have to have satellites, as David, mentioned in his great slide. We have to think about service level agreement. We have to think about the redundancy, because we're talking about to build mission critical services over a commercial network. So the commercial network, although it is there, needs to be forged, fortified, and needs to be modified in order to accept mission critical services. And the rule here is this: the more you own, the more isolation you have. If you have let's say, of a Tetra, you have to spend more money. But if you have, let's say, in a country that is start taking the transition from Tetra to 4G and 5G, there are intermediate steps that you can follow in order to have this investment and network build up gradually. So here we have, let's say, here one topology that came from the GSMA Association. And right here, what we're doing with David, it is we have a single cell network or network as a services. We're using plenty of, let's say, virtualization, if I can say, assets that allow us to do all this testing. The testings are irrelevant with virtualization, but this is kind of a model. So to be more specific, this is kind of a Tetra network. So you own everything. You own the devices, you own the spectrum, you own the core, and you own the services. And so far, this makes sense for everybody that says, okay, if I have a narrowband mission critical network, why I cannot own, let's say, this broadband mission critical services? It is the cost and the complexity that makes it really challenging. And so far, what we know, only one operator in UAE, NEDA, has, let's say, make plans to have this kind of network. All other networks, let's say, will be, let's say, partially owned, partially supervised with some commercial operators. So this is one, let's say, network topology that makes sense for everybody. You own your network, but you don't expect to have coverage throughout the country. So you would expect to have some, let's say, sharing of, let's say, resources and run with, let's say, the coverage with a mobile network operator. So if you think naively that, okay, the more network operators I will have, the better it will be, it's not that straightforward, because it adds complexity, because your own network has to have, let's say, links in your working with all the other, networks that are in the country. So imagine you have, let's say, a network by Telecom, a network by Vodafone, and you have your own Tetra network. all these three networks have to be, let's say, in alignment in order to be ready to support first practitioners when you have, let's say, a big incident. So it is not that straightforward. And it is not that straightforward. However, the Americans, they have done it first, but it also took them, many years to do that, because the Americans, they use it, what they call first net authority. And first net authority was established as a concept in 2012, but it took them 6 years to launch a network. And over there was things were more, let's say, straightforward, because it was one country that says, this is going to be my network and you have to use it. In Europe, we have many networks that have been developed in a different point of time, and all these networks have to be interoperable and actually uniform with each other. So in order to have, let's say, first responders from Romania coming to Greece to assist with a, let's say, forest fire, these networks have to be, let's say, homogeneous. The people have to have the same level of services that they have in their own country. And when they transition from Romania through Bulgaria to Greece, they have to have the same kind of network coverage, the same services. So we're not talking about a single network, we're talking about many networks together. That's why the European need this system of systems. That's why we need this kind of, let's say, interoperable phase between each other. So that will be my last slides, just to sum up what will be the main differentials. So mission critical services can be deployed over 4G and 5G. This is the trend. What we have seen from the testing, technology is there, but we are not completely there yet. We have to ensure openness, we have to ensure open protocols, we have to ensure they're working about Airbus, Tetronics, Leonardo, and all these great players. So it is more challenging for them because each one has its own technology solution, but in Europe, we will going to have all these solutions. So system of systems adds more complexity. So service has to be guaranteed in order to be, let's say, better than the Tetra. So knowledge and training, it is going to add more complexity. It's not that straightforward to move something that was, let's say, a network for 30 years to a more sophisticated new AI network that is today, because you have to train people, you have to allocate resources, you have to do many, many things. And also you have to have, let's say, the planning, who's going to do it in your country. So it's going to be more complex and things are going like that. So all other stuff, they're going to be, let's say, challenging, but most of it is also governance, who has the ownership. Each country has to have its own, let's say, structure and has to be in alignment with other EU structures. So control, accountability, and all these things are more complexity. So it is very interesting, but very challenging services. That's why it is very, let's say, interesting to stay in touch with the evolution, aligned with the EUCCS preparation project. And as David says, try to find the latest from the conference. And that was all. I will actually thank you for your, let's say, attention. I will more than happy to address questions. And without further ado, I would like to leave the floor to Nicolas, the next speaker. Thank you so much.
Thank you. And it was really interesting to see the evolution, and also that we are going to more complexity, to more distributed network with the system developed in Europe, and somehow it increases the resilience if we have different operator, different technology. So it's interesting to see also the comparison as you have made between the how it's developed in Europe with so many member states and how it has been addressed in the States. So thank you very much. You have also one question in the chat that you can answer after the presentation of Nicolas, and the same for David. You have a couple of questions in the Q&A part of the webinar that we will take after the presentation of Nicolas. So Nicolas, you have taken the control, and you can. So it's a pleasure to welcome you, and we are listening to you regarding the industry perspective and to have some illustration of what kind of technology brings this resilience.
Thank you, Olivia. It's a really pleasure to be here, and thank you for inviting me to present. My name is Nicola. I am one of the directors of a company called Accelerate Technology, and we are a technology and innovation company. We work directly with governments, end users, operational end users across the first responder community. So that is everybody from civil protection teams, ambulance and emergency care practitioners, fire rescue, and kind of international deployment teams, and also police and security. And we also had the fortune of winning and being awarded a DIREKTION award for quite a specific technology, which really does thread through to technology that can be used to support things like EUCCS in the future, and really complements actually the two presentations that you have just seen. And it is our hybrid edge technology. It is technology that was developed within our innovation team and our innovation division directly with the European Space Agency. So I'm going to actually take you to a video where I can explain this technology, its journey, and hopefully how it can support. And then following the video, I will just run through simply some case studies and user case studies, and the type of operational environments that this technology today is actively being deployed, not just within Europe, but also further afield in the likes of the Middle East, into New Zealand and other global territories. So over to the video. Hopefully that gives you a good insight into this technology, and you can see how this might fit with the bigger picture going forward.
Hybrid Edge is a cross-functional innovation developed as part of a European Space Agency project. The technology resolves capability gaps identified by the DIREKTION Consortium and recorded by the International Forum to Advance First Responder Innovation. It offers a resilient, ready-to-deploy technology and communication platform tailored to the needs of practitioners and policymakers. The scalable solution supports remote operations with instant access to robust communications, interoperability, and real-time information sharing, enhancing decision-making and responder and civilian safety. Hybrid Edge addresses several key challenges: reliable connectivity in remote areas, real-time data sharing, interoperability across agencies, responder safety monitoring. Hybrid Edge ensures continuous, interoperable communication regardless of infrastructure limitations. Hybrid Edge supports secure integration, allowing the hosting of application and data from wearables, sensors, robotics, and unmanned systems to deliver real-time situational awareness, improving coordination and response efficiency. Hybrid Edge enhances responder safety through real-time geolocation, mapping, and integration with wearable technology. The system provides data, access, connectivity, and secure video streaming, even in low visibility environments. Hybrid Edge improves operational effectiveness, safety, and coordination across diverse emergency response scenarios. Designed to interoperate with existing communication systems across various environments where remote operations and resilience are vital, one of the Hybrid Edge's standout innovations is its multi-network adaptability. It seamlessly switches between any available network, merging them into one unified, secure connection without being tied to specific providers or infrastructure. It also includes a user-centered management interface designed for rapid deployment and ease of use, and real-time data fusion, creating a comprehensive operational picture. Applications span mobile, deployed, and fixed environments, such as vehicles, temporary field units, and specialist response systems. With active deployments connecting users across 7 countries, including Europe and the Middle East, with expansion to 15 countries expected within 12 months. Hybrid Edge is solidifying its position as a leading solution for operational resilience in high-risk environments. Accelerate Technology has built a strong cross-functional team committed to delivering advanced technology and communication solutions to civil protection, first responders, government agencies, and mission-critical sectors. Our mission is to deliver the right technology at the edge of every application.
So I hope that video it provides a really short and succinct overview of the technology Hybrid Edge, which was delivered as part of a European Space Agency programme. I mentioned as an organisation that we work across many diverse sectors, and you've seen some of them there, and not always in that kind of mission critical environment. Accelerate is also exposed to other more kind of private organizations with different types of operations, and sometimes they can be on the land, it can be land mobility, it can also be offshore environments, but fundamentally when we're working with organizations either to problem solve or develop a system of systems approach, or a kind of end-to-end product, or an end-to-end solution for a problem, fundamentally majority of the cases people are coming and talking to us with the same problem, and that same problem has existed in all the years we have been working, which is over 23 years now, and it doesn't matter about what infrastructure goes in behind us. As David said in the beginning, the infrastructure and the type of technologies that you will start to deploy as your core mission critical services, there will always be instances where coverage, potentially network issues and network availability is going to be a challenge. And we're right, George is right, this is complex behind the scenes, but actually the experience on the ground at an operational end user is you simply think, I can't use my device, I can't share this data. So we sit with organizations at that very operational level to deliver operational technology to try and overcome some of those issues. And you will see within some of these images and my next slide some images of the types of solutions that we're working to. So the picture here actually, which I'm just kind of using with my arrow, this is emergency, this is the mission critical capabilities for one of our nuclear customers. It is a nuclear customer based in the UK. And the nuclear industry has quite strict and stringent regulations, and took in lessons from things like from Fukushima, and now have a dedicated and quite specific response to how they would manage such disasters going forward. And they're also a really good example of a specialist emergency response team where maybe ordinary emergency responders may not kind of enter into that environment. However, the need for emergency responders and other agencies to interoperate and be able to communicate with what's going on in that environment, because that type of disaster will have significant impact to society and communities around it, is really, really critical. So there's a really good example where they have a large area in which they need to cover. They have issues potentially with certain types of communications, one from a security point of view, and two actually from a location point of view. So how can they start to use radio, but could we interface and interoperate radio over satellite, for example, how can they start to have a multi-agency type coordination with other emergency responders? And they came up with a kind of whole capability of what they needed to deliver over within their environment, but also more importantly, how that would need to kind of interoperate with other environments. Also things like, what systems go in to be deployed is, there's a really good example, hardened radiation type nuclear cameras. They're already using them. They're really good legacy systems. They're fit for purpose in their own environment. However, useful data and useful information would be to take that video stream and be able to share that both to commanders on scene, back to strategic coordination centers, and also back to other types of emergency responders. So what we essentially do or have done in that environment is put things like the hybrid edge capability in there so that we can have not just a systems of systems approach to how information can be shared, but also a network of networks approach, which is what you saw in the video with this ability for satellite, cellular, other types of communication, sometimes non-terrestrial communications. So that might be private cellular networks, that might be meshed based services and solutions. So if you can start to have a hub, if you like, or a centralized hub that lives on a vehicle or lives in a portable device of some description, but can plumb in any number of communications channels that you choose to, and that can be things like EUCCS going forward, but it can also be another type of backhaul service. It can also be things like LEO satellite services going forward. If you're familiar with LEO, Starlink is a version of a LEO satellite service. In Europe, you have OneWeb, Eutelsat delivering these types of services, and this network of networks approach is going to be fundamental, because as we need more data, more IoT systems, more of a demand for video, for voice, images, mapping solutions, whatever is coming out is really, needing more data. We also have to be realistic about the ability for a network and a single network to be able to handle that much data, and the reality of whether it should also handle that much data, or whether we can start to be intelligent with how data can be transferred across different types of communications bearers. So not only are we starting to look at different networks and different infrastructure, but actually we're starting to now go, I now need this data to be intelligently shared across lots of different user groups, potentially prioritized over something else. And that is what the hybrid edge technology delivers. And fundamentally, it is a centralized hub that can live in a vehicle, it can live in a portable system, and it can start to bring all of these different communications bearers together, not only develop a complete ecosystem of different networks, but also bond those different networks together so that we can start to have a much bigger bandwidth or bigger capacity for sharing this kind of data that we're starting to look at and talk about. The next slide, again, you will see a variety of different customers of Accelerate. So, we have police operations, drone teams, using UAV streamers, UAV and unmanned systems to deploy across large scale areas. We see the same in fire and rescue and certain response environments, use of this technology for wildfires, for example. But one of the challenges that we find or we are asked to solve is sometimes we have a drone and it's going to go up in the sky, but they cannot see the image or the video beyond the controller or beyond the operator. So how can we share that securely, not just within our own organization, but also share that across multi-agency teams? So this technology is very agnostic about what is plugged into it, device-wise and system-wise, but it is very secure and enables a very secure way in which to share data across actually quite a complex network, and sometimes lots of different agencies or organizations who, as you've pointed out earlier, also have their own policies, their own infrastructure maybe, and sometimes that is the challenge to sharing information, not necessarily the technology. Actually, Hybrid Connect was also used quite extensively for emergency care, and is not just from the emergency response side of emergency care, is a really good example. And we learned this, during the pandemic, where, how do we start to treat people or care for people at home or in a remote environment without maybe always transitioning people to hospital, because that is overloaded or they can't come into the hospital. A ambulance or is sometimes having to go to an urban environment, a rural environment, and sometimes transfer vulnerable people or people with quite significant health concerns who need to be monitored 100% of the time across quite long distances, and therefore require a link, a continuous link with a specialist clinician who might need to be looking at those. So you start to look at how the movement of the vehicle, the movement of people into homes, the movement of patients, and you start to realize that how can we create a ubiquitous connection that can transit all of these different landscapes that we travel in a vehicle, or sometimes beyond a vehicle. We have to get out from a vehicle and we have to go somewhere. Emergency situations, as you know, they don't have borders and they don't pick the perfect spots. Whether it's a train derailment, whether it's something that's happening inside a building, perhaps it's something that's happening offshore. All of these things pose significant challenges to how our ordinary devices or systems that work perfectly in a training environment, how can they work in these very non-conventional environments? And the reality is we will start to need to look at technologies like we are deploying now within organizations that are more resilient or more adaptable, and to kind of the standard devices, the day-to-day devices that are being used, but things that actually can be deployed with you. So an anywhere coverage type of capability that really enhances organizations' ability to respond across different types of incidents, and also create technology that can be scalable, can be interoperable. So we've got really good use cases where a police force is simply wanting to kind of do crowd control, and actually they might be using things like facial recognition technology. So how can a system be deployed into a stadium, for example, which is very traditionally difficult for mobile communications because the network typically is overloaded. We have lots of public there, lots of use of devices there. So how does that emergency capability, or the command capability of what's going on there, deal with that? Well, there is technology that can be deployed, and it can interface with organizational systems and each organization's capability, whether that's facial recognition technology, whether that's their own control room systems in the background. But the focus for us is delivering deployable technology. And sometimes that's in whole command and control vehicles that you can see here. Sometimes it's in portable units that you can see here. So it's really scalable in terms of how it can be delivered, but fundamentally is looking at how it can connect to all the different networks, enable you to connect all of these different systems and devices, so that actually we can in large scale create what is being asked for. But this has already been delivered in deployable environments, but it's a per organizational basis at this moment in time. So it will be very interesting to see how this type of technology or some of the capabilities that are being deployed in an organizational sense can also start to leverage the benefits of David, the EUCCS network, and overcome the challenges that we do face within Europe for enabling critical, mission critical communications in every single type of deployment that there is. This is just a very typical environment. It's my last slide. If you're a responder, you will be more familiar, with what you have to set up. But it really does demonstrate, when a deployment happens, whether it's single operator or is multi-agency or is at greater scale, there are significant assets and teams being deployed, and it is complex. If it's in an urban environment, you have the complexities of buildings. Are you inside a building? Are you underground in tunnels? And the movement, the identification, and the reality is we're all starting to use really clever technology, but it is actually quite all isolated. So this type of technology that we're talking about that's been developed with the European Space Agency is about almost bringing some of those things together and enabling a resilient ecosystem and a resilient network to be taken wherever you are, and fundamentally plumb anything into it. So it's very agnostic with the type of systems it can plug into it, and the type of services it can start to host on that network to really provide a interoperable solution for resilience purposes. If anyone has any questions, please let me know. The video is available via the link. You can also go on our website, where there is a whole host of information and use cases relevant to all the different sectors that we work in. And I am on LinkedIn, so if anybody has any direct questions that they would prefer to communicate with me more directly, please don't hesitate. But thank you for your time, and it's a pleasure to join you today.
Thank you very much, Nicola, for the illustration. Thanks to your presentation. There are several questions. Some of them to the first speaker, for the second speaker, and also the last one. Maybe we can start with the first one. Maybe I ask all speakers to turn on the camera. I hope you had a chance to look at the question. So from Borut is a sort of reformulation of what is the EUCCS. So it's a standard for a safe communication protocol between different ICS management app using different country, or is it more than that, David?
Yeah, when it comes to interoperability of information between countries, that's a different layer of what we're challenged with at the moment. But the information, recall I presented the layer diagram, yeah? So the information interoperability there. Between an app and some kind of application server, and between those servers and other servers, and those apps and other apps in those servers, that is often a challenge faced I would say, on a different level to what we're doing. Yeah, not this one, but the layer diagram. It's a nice diagram, of course. But what I'm trying to say is the pre-existing communication protocols on an information level, they will interoperate over EUCCS, but the actual agreements of how those protocols will interoperate will be quite different to what we're achieving. But this is our, to be honest, our next challenge in the next year or so is figuring what protocols on the information layer need to be interoperable for users of EUCCS, because every user is using different apps and systems and services, and it's about harmonizing those, really. It's tricky. That is a trickier question than the problem we're trying to solve, to be honest, in trying to interoperate mobile communication. But the actual interoperability of the information services, that's a different layer. But it's a problem I'm very well aware of and very keen to explore what's the specific problem, because in the question written, I don't actually understand the question, to be honest.
So I think there is more than the standard. There are some piece of legislation also related to this communication system. This is what I have understood from Oliver Seifert when we were also preparing this webinar.
Yeah, it's again, we need to understand what the problems are to be solved and what will be in the regulation. EUCCS regulation, how much detail. It's very likely that the information layer interop will be won't be in the primary EUCCS regulation, but will be part of the implementing acts that come thereafter. So we need to understand more about what's needed there. In this question, I need to understand what the real specific problem is that's faced, and then we can drill on that, because we can actually study that in more detail in the program.
Okay. There is another question from Michael Unterhalt about the sovereignty. Who would like to address this question?
So well, I can anyway, because in the regulation we are looking at with sovereignty, the strategic autonomy is part of the operational plan of MCCG. Sorry, George, go ahead.
No, I think you can start, and then George can take over, or it's important to have a different point of view on this very relevant question.
Yeah, so sovereignty, I would say, you'll see the 4 contractors we have are European. We do have issues procuring. The procurement processes don't easily restrict only European at the moment, but we are looking at that. But it's a real problem in that not everything can be European supplied. This is a problem. This is something we're aware of, and something that we are doing our very best to make sure this is only European. A lot of this is in the procurement laws. This is where the challenge lies, because we can't be specifically focused only on European supply, the way the laws are written at the moment. But this is something that's moving. This will change.
George, you have some additional comments or different point of view?
Yeah, no, I just want to add some clarity, because I was also the one who also, mentioned this kind of, let's say, of military synergies. So EUCCS, it's not has to do complement or, substitute military system. However, in many European countries, Army or Air Force has some assets that civil protection and first responder don't have. So depending on the country, some, for a case in evacuation, in Greece, at least the Army has these Chinook helicopters, and I can share, a screen if I can do it. Let me see. So you can see my screen. It is Army. It is EUCCS has nothing to do, but where is kind of, let's say, of disaster, and the whole situation, the whole city and big area is flooded, then you have to evacuate people. And sometimes, in certain countries, Army has this capability to evacuate people. So we have to ensure, at least in our national EUCCS component that Army will have, let's say, EUCCS capabilities. They can communicate with other first responders like police, fire brigade, other officers, so they can do the evacuation. So we don't complement, military. EUCCS has nothing to do with defense and military, but in many countries, when there is kind of disaster, we might need to incorporate the defense element for safety and security exclusively. We have nothing to do with, let's say, military protocols and things like that. So I hope it is more clear now. And then I believe Olivier was the other question, was also about hardening, because there was some nice example what will happen, let's say, for example, in France, in Spain, after these power outages. A few things. EUCCS is going to be around some commercial networks, and we have to think about hardening. And one of the challenges, at least in the national level, it is the commercial network is built around coverage. So I'm covering, let's say, 99.5% of Greece, but we don't cover 99.5% of the population. And this is very challenging. So in the middle of a forest, there is no need to have, let's say, silver coverage, but sometimes, yes, we do have, let's say, some, let's say, need to deploy, first responders for certain reasons. Then it comes into the play, deployables, and actually Nikolai is more eloquent to say that, because this is what we have envisioned the network. In case there is no coverage, or in case there is need to add more resources, to have deployables, and actually solutions like Nicola have presented. So this kind of portfolio, they will be part of EUCCS, because we're talking about Leo, we're talking about these capabilities, we're talking about deployables, and all these things will be part of the EUCCS when there is a need. And actually hardening the system, it is part of the regulation in many countries that have been debating right now. We have seen from 8, we have to 4 times, scale up the network to be more durable, but that's the plan. But, I believe Nicola will be more, let's say, expert to advise on this deployable and how these deployables can compensate some of the weaknesses of a, common network.
Yeah, and to complement also the questions that you passed to Nicola, I think there in the question from Javier Larrañeta, we had also the question about the cohabitation between old and new system with the Tetra and the 5G, and also in case of we lose the electricity, there is a blackout. Are there some battery? How is it organized to maintain the network? So please, some practical answer and short answer.
No, I think in the deployable capabilities that we are seeing, it is about having a resilient capability that you build in resilient power, you build in a resilient network, and again, battery operators, generators can come in and start to power these systems in the very specific case of power outages, which are happening far more regularly now. But this is a completely either standalone network that when coverage is not available, or it is compromised, or it has been wiped out because of the type of disaster that it is, deployable capabilities are now a normal consideration. They have always been there, but in a more of a failover perspective and a more of an insurance perspective. I think what we are talking about going forward is having this understanding that you need it all. There is no one network that is going to sustain everything that we and that you need to deliver, whether that's from a data perspective, a security perspective, a network perspective, the availability, the coverage. So actually, for us, in the sense of when I talk about hybrid communications, hybrid technology, it is about understanding we have to start to have a approach that has your EUCCS of the future, like you're used to using Tetra, like you're used to using your mission critical services now. And that is one layer, that is one aspect that won't change. But however, we're going to have other capabilities to maybe deliver certain types of data, and actually maybe it's a better network for doing it. And we haven't got into the complexities of how do you make this more cost effective, but the reality is, by looking at this and being able to intelligently manage how data is shared over different types of networks, whether that's on a day-to-day norm or because there is specific circumstances or types of deployments that always need you to be on LEO satellite services, for example, then that's where you need to be. I think the really good thing is the things that we're seeing as well, the types of devices that you're starting to look at going forward, the reality to the end user, if this becomes really holistic and tied up across the different ecosystems that have to coexist with one another, actually devices don't change. The tool that the operator or user isn't being switched out. It's about how it can transition securely onto these different things and be used as an interoperable solution onto all of these different networks. And that currently is a big challenge across most territories, usually for commercial purposes. So commercial policy or policies are sometimes the barrier for technology interoperability. And I think that where David and where George, what they're trying to map out here is this shouldn't be a barrier anymore. It doesn't need to be a barrier anymore. There are companies like ourselves, it's not a barrier. We thrive off interoperability, but we need to stop doing this in a small scale environment. And we need to start thinking about this in the much broader term and using really good principles that are being used to deliver and respond to incidents now, and have that as a standard practice going across the everything that we do, and then everything will become a lot easier. Training, cognitively, we're there. This is how we develop. We deliver it on a day-to-day basis, not the ad hoc basis that sometimes happens, which also can be problematic for organizations going forward. So I hope that hopefully answers it.
Thank you. And I think it's also linked to the question from Sylvia Okrasa, which is about how the system, the EUCCS, also address the congestion or define some priority for critical users of the network. Is it addressed already in the preparation phase? How you will give the priority and maintain the availability, even if the rest of the network is congested?
Yeah, absolutely. This is one of the primary concerns in the EUCCS consideration is quality priority preemption. This is an element within the 3GPP standards which is available, but the commercial mobile operators don't really easily turn it on. But in the regulation, that will be a mandatory feature. So when you're in that sports stadium and the responders will need to push and speak or push and video or communicate in data, then that's where the QPP will step in and give the responders a higher priority on the network over the public. So that is definitely a key consideration. And back to the resilience issue, the point of the deployables, this is a primary concern within our consideration. So we expect the deployables. We also expect direct mode device to device. This is coming. We have some good, I would say, technologies coming towards the ability to provide device to device communications. We're also talking with the satellite to direct to device. All of these factors to do with the resilience where the power outage is there, because it's going to be far too expensive to put battery backup on every base station across Europe.
No, it's definitely not feasible, I guess. Yes.
Yeah.
So I think Sylvia was happy with your answer. I have seen a thumb up. Anything else you would like to add before I close the meeting? I think from my point of view, being not a specialist on this topic, so it has been very informative to see that the European Union is preparing this kind of tool, which is for the benefits of all citizens in case of crisis. That the technology is evolving quite fast, but it's a long process also of building on the different technology with the technological progress. And the illustration from provided by Nicola was very useful also to see in which situation we can need this critical this communication system that brings the resilience. So I would like to thank you all very much for your participation, for preparing the webinar, for sharing your view, your knowledge. I would like also to thank Bastien for organizing the back office and preparing everything, the communication and the managing the tool. So I hope all participants found it interesting, informative, and please look at the previous webinar and get in touch with us for the next one, which will be on scanning the hazardous substance in case of a disaster. So it will be the next one on the 27th of February. Thank you all again, and see you next time. Bye bye.
Thank you.
Take care. Bye bye.